In real world, the threads can be managed on both user level and kernel level. The threads which are managed by user level threads library are called user thread. On the other hand, the threads which are supported by kernel are called kernel thread. So nowadays, all contemporary operating systems support kernel threads. So for example, Windows, Solaris, Linux, Mac OS X. Kernel threads are more powerful because they are managed and aware by kernel, so they can achieve real concurrency, even parallelism. If multiple cores or CPUs are supported in the computer system. However, the downside of a kernel thread is that since the kernel thread are aware by kernel and maintained by kernel, so creating kernel threads may introduce more overhead than user thread. So that is why in real-world operating system, there is a limitation when create kernel threads. So which means you can only create limited numbers of kernel threads. So you cannot use more than that. Otherwise, it will bring too much overhead into the kernel to create them and maintain them. Then you may ask that, so since we have a user threads and the kernel threads, so what the relationship between these two types of threads? Actually, there are three widely used multi-threading model to map the user threads with the kernel threads, so which are named many-to-many, one-to-one, and many-to-many. So in later slides, we will discuss them one by one. The first one is called many-to-one multi-threading model. From the name, you may already know that multiple user threads will map to single kernel thread. So since multiple user threads map into one kernel thread, if one user thread is blocked, then the only kernel thread will be blocked. Then all other user threads will be blocked as well. And also, since kernel is only aware the single kernel thread, so those user threads cannot run in parallel, even though you have multiple cores or CPUs in your computer system. Because the kernel thinks that there's only one thread there. Although those user threads can run alternatively or concurrently, but they can never run in parallel because those user threads only map into one kernel thread. Nowadays, only few systems currently use this model. For example, Solaris green threads and GNU portable threads. However, they are only used to exploit the concurrency on multi-threading, but nothing more than that. The next one is a one-to-one mapping. From the name, you may know that when you create a user-level thread, a kernel thread will be created to map the user thread. Since each user thread maps to a corresponding kernel thread, unlike the many-to-one mapping, the kernel will be aware the user thread in one-to-one mapping. Then the one-to-one mapping can support more concurrency than many-to-one mapping. So even parallelism if multiple cores or CPUs are available in the system. And also in one-to-one mapping, if one user thread is blocked, only the corresponding kernel thread will be blocked. It won't affect other user threads. However, since creating each user thread will create a kernel thread, and the kernel thread creation is more expensive because to create a kernel thread will occupy more system resources and bring more overhead to the kernel. Therefore, the limitation of creating kernel thread will confine the number of user thread. So in real world, we have numbers of operating systems which support one-to-one mapping. For example, Windows, Linux, and Solaris 9 and the later versions. The last model is many-to-many mapping. This model can provide you the more flexibility than other models. So in this model, many user threads can map to less or equal numbers of kernel threads. So for example, we have 6 user threads, so they can be mapped into 4 kernel threads. So if one user thread has been blocked, only one kernel thread will be blocked. We still have 3 kernel threads can be used to map other user threads, unless all mapped kernel threads are blocked. And also, since many user threads can map to many kernel threads, the number of kernel threads won't confine the number of user threads. So for example, we can have 1,000 of user threads and map them into these 4 kernel threads without any problem. Therefore, many-to-many mapping model can support more concurrency or even parallelism without limiting the number of user threads. Then we may have this kind of a situation according to the above mentioned example. So if 4 user threads who mapped to the 4 kernel threads are all blocked, the other 2 user threads can still run? Unfortunately, the answer is no. Then some students may ask that, how about one of the other 2 user thread is controlled the refreshing of user interface, so which should be always mapped to a kernel thread without blocking. Otherwise, we will lose the responsiveness, right? So in that case, does that mean we need to use a one-to-one mapping model? Actually, later you will know that a variation of an original many-to-many model, which is called two-level model, can address this problem. It allows a user thread dynamically bounded to a kernel thread so that other user threads cannot block it. For example, the user thread who is in charge of the UI can be dynamically bounded to a kernel thread similarly as one-to-one mapping, like the red figure showing us. So even though the other kernel threads have been blocked by the other 5 user threads, the UI thread won't be affected unless it itself causes the blocking. So later, if the user thread does not need to bound this kernel thread, the dynamically bounded kernel thread can be returned back to the group of other kernel threads. So here you can see the difference between one-to-one mapping and the two-level model. So you cannot do the rejoining in one-to-one mapping, right? So even though this model can provide you more flexibility there, but this one is the most complicated model. So nowadays, due to the higher ability of the hardware, so which can provide more system resources, one-to-one model is widely used in most of the operating systems. So therefore, only Solaris operating system, actually the version before version 9, use a many-to-many model.